everyone, and welcome to our podcast, Step T with Elsayed. Today, I'm really overwhelmed because I have a very special guest to me today. He was my supervisor during my postdoc, and I learned a lot from him. And I will share with you soon a couple of things I really learned from him for my life, not about the technical stuff. Our special guest today is Dr. Wayne Parker. Dr. Parker is a professor in Civil and Environmental Engineering Department and cross-appointed at Chemical Engineering Department at University of Waterloo. Dr. Parker is a well-known name in our domain. So when we say Dr. Parker, you don't need to introduce him. He's a well-known professor, both nationally and international, on the water sector domain. He has received many awards and recognition. And when he was young, he received that Petro-Canada Young Innovator Award. So this is something, since he was young, he showed that he's an excellent researcher. He also received the Province of Ontario Premier Research Excellence Award. And also he received the WIF, William Rudolph's Medal. And I think that was 1994. So since a long time, Dr. Parker is showing his excellence. It's a pleasure meeting you, Dr. Parker. How are you doing?
I'm doing very well, thanks.
It's really an honor to interview you today.
Oh, thanks for having me.
I just want to share something I really learned from you when I worked with you outside all the technical stuff and the academic things, and I'm really using them. The first thing that I learned from Dr. Parker is how to be a professional, even with people that have a conflict of interest or a conflict with you. Even if you don't agree with those people on the way that they are dealing with the stuff or their point of view, how to deal with them professionally and how to separate that your mindset or opinion and working with them as a colleague or a student or a member of the community professional. And this is something really you learned by experience with Dr. Parker. And this is something really impacted me and it stayed all the time with me. The other thing that I learned from Dr. Parker during that short interaction with him, that is, you don't need to jump to reach the top. If you go step by step, consistently, you will reach the top. When there is a chance to jump, you can jump. But reaching the top, it's not always through jumping. Just be consistent. Work can be slow, but consistent, you will reach the top. And that's something I learned from him and from his career. So that's why I'm really honored to have Dr. Parker in our podcast today. By the way, what is your favorite drink?
My favorite drink? Oh, it's probably a nice IPA beer.
Did you try the Step Tea before?
I've had tea of various types, yes.
Okay,
yeah.
So we have a very special tea and have our own recipe for the tea. So let's maybe try our own Step Tea. So this is going to be totally different from the other tea that you tasted before. And I hope that you're going to like it because we did a lot of research to come up with the recipe for this one. Okay, so Dr. Parker, are you ready to jump in the time machine?
Sure, I'm always happy to talk about my past.
Yeah, so going back, what inspired you for that environmental field or a professor?
Well, I was trained as a civil engineer, and so had relatively little exposure to environmental engineering, with the exception of a couple of courses as an undergrad. I did do some work terms that were environmentally related, and I think that kind of got me going down the path of graduate studies as, initially a master's student and PhD and so on. So I had very early on an interest in anaerobic processes.
Oh.
Going back to the mid 80s. And at the time, there was a lot of interest in anaerobic processes for industrial wastewater applications. And so, in fact, that's what I did for both my master's and PhD work. I did my master's work here working with like a petrochemical waste that was, we were trying to find an alternative way to treat, and we looked at anaerobic processes. And then I had an opportunity to visit people in Burlington at the Environment Canada Wastewater Technology Centre at the time, which was a very dynamic place. There was research going on almost all aspects of wastewater treatment and sludge handling, and so I talked to people there, and I learned a lot about what was happening. And when I came back, I thought, geez, if I'm going to do a PhD, I'd like to do a PhD there. And so, in fact, that's where I asked if I could come and research there, and they said yes. And so with that, and it was really working at the Wastewater Technology Center at the time, I think, was really what kind of launched me, I feel, right? And just in terms of the exposure that I got to so many different aspects of wastewater treatment and waste management. And, I was working in a group that did a lot of biological process research, and at the time it was pulp and paper wastewater treatment that was a lot of what was happening. And I learned a lot about that. But then I looked around and I saw what other people were doing. And, so at that time, Andrew Benedek was just getting going with the membrane bioreactors, and that research was happening near there. Gilles Patry was getting going with the first wastewater process simulators, and so there was collaborations with them, and so that was a very interesting operation to interact with. They were doing some of the first pyrolysis work, so they were doing what they called oil from sludge. At the time, and basically they were pyrolyzing biosolids to produce oils, and so there was just and those are just a few examples of the kinds of research that was going on. So I think that having that exposure and meeting the people that were there, were very highly qualified, and many of them have gone on to very successful careers in a variety of sectors: consulting, technology, academia, government, and so that in itself has really helped my career, in that knowing all of those people and having that network of connections through the industry was really a significant, I guess, step, I think, in my kind of advancement. And I left there and I went to work for a consulting company that was really a spin-off company from that operation. We were doing process engineering and looking at that time, the emerging compounds were mostly industrial related compounds, so volatile organic compounds, heavy metals, and so on, and looking at them. We did some model development, and so I worked there for 4 years, and then I moved to Carleton University in Ottawa. And Carleton at the time was just starting their environmental engineering program. It was only in the 3rd year of the program. Most of the courses had not been taught before, so we were developing curriculum and teaching it along on the fly. And so it was a busy time. There wasn't a history of environmental engineering at Carleton prior to starting up the program there. So there were no real labs to speak of, and so we kind of had to build up research labs and get them up and running. And so I was there. I was in Carleton for about 9 years, and I came back to Waterloo and have been here since, and conducting a variety of research topics here. Yeah.
It's a very rich journey, early start journey, but moving from civil engineer to environmental field, like and dealing with biological treatment and thermal treatment as well. You mentioned pyrolysis. How would that move from just, civil engineer, like, does not have that much background in the environmental engineering discipline. So moving from trained in civil to an environmental sector, how would that move?
Well, it was a challenge. In fact, I say that I learned more about chemical engineering when I was a PhD student than I did about civil engineering, because I kind of looked to tried to understand what skill sets I needed to have to be able to do the kind of research that we were doing, and it was largely principles that were from chemical engineering, reactor engineering, reaction kinetics, and some chemistry and biology as well. And so I read a lot of textbooks.
Okay. I can imagine, because I have the same path. I'm a structural engineer. My passion was structural, and then I moved now to environmental engineer. So I can imagine the challenges in the beginning, understanding the biochemical reactions and the chemistry and biology. But another thing that takes my point, when you shifted from industry to the academia, so you did your PhD, you worked for the spin-off company for a few years, 3-4 years, and now when Carleton opened their department, you moved to Carleton.
Right.
How was that? Take us back to that moment. How did you decide to go from industry with, I would say, good paid, compared to academia and go to the university? How was that decision?
I think at the time I sort of was contemplating both pathways, I guess, for a career. Certainly, I was the work that we were doing in industry was interesting and challenging. But while I was there, I was also kind of keeping my feet wet a little bit in academia. I became an adjunct professor at the University of Guelph at the time, actually.
Okay. So it's always there.
So I kind of kept that up a little. Like I did some teaching, I supervised some students. And so I guess I kind of was thinking about academia for a while. Okay. But it was not a time when there were a lot of academic jobs. Actually, the economy was in quite a significant recession here in Canada at the time, and not a lot of universities were actually hiring faculty back then. And so a position came up at Carleton, and that I kind of chose to move that pathway. Yeah.
So going more back, did you think that you're going to be a professor when you were a child? When you were a child, did this come to your mind?
No, I had. So I was the first member of my family, of my extended family, including all my cousins, who actually went to university.
Oh.
And subsequently grad school as well. So I really, where I grew up, I had very little exposure to universities. Actually, I went to university sight unseen. I had not even visited a campus before I chose the university and came here.
Wow. Yeah. That's really inspiring, son. That means that you inspired a lot of members in your family after that. Yeah.
Well, I hope so.
Yeah, during our life, there was always people that is impacted our life, and I'm pretty sure that is your journey impacted a lot of members around you and a lot of family members around you. So during your journey, do you remember someone who really influenced your career or your life?
So I think I've had a few people who I could say that I've looked to, because I've seen some traits, or they've done things that in a way that I really thought was done well. And my graduate supervisor, Graham Farquhar, he was a fantastic instructor. He was probably one of the best instructors that this department has had, going way back. And so I think I learned a lot from him about teaching, about how to engage students and how to teach in a way that kept students sort of attentive and so on to in the classroom. And I've tried to always emulate that a little bit. I had my first employer when I worked in consulting. I learned a lot from him about persistence. His name was John Bell, and he was the president of the company. And when we were, working through problems and so on, I was always so impressed that he just never let a problem drop. Right? He would always keep coming back to it, try to think about it from different angles, and try and find a solution to it. And so I think I've tried to emulate that as well. When we have challenges with research, think about, is there a different way that we can approach it? Can we try a different angle and persist until you've kind of exhausted all options? And in academia, I've had parts of my career when I've done a fair amount of administrative positions, and I had the luck and the fortune of working with Elsayed here at the University of Waterloo when he was dean here, and I just had an opportunity to see how his vision and his style of leadership I really found enjoyable. That he really trusted the people that worked with him, and he delegated responsibility, and he listened to ideas, everybody's ideas, before making kind of a decision about how to move forward on issues. And so I think I've learned a lot from him about university administrative practices. And so in each different aspect of I guess my career, I think I've seen had very good role models that I've been able to learn from and try and integrate into what I do.
Yeah, so on your behalf, I want to say thank you to all of those people who really influenced you and you're such an amazing professor and fellow. But quite interesting that you get engaged on the admin side, and we have that kind of mindset. If you get involved on the admin work, you will drop the research. And that's why people always telling us, be careful. If you accept an admin job, that will affect your research significantly. But we are on the sector, and we didn't see that with you. How did you make that balance?
Well, I always did try and keep my graduate student supervision going. Try to carve out time to keep research going, because most administrative positions, they end, right? And for most people, if you're doing whether it's a departmental chair position or an associate dean position or others, you don't tend to do them for your entire career. And I think, at some point, you'll probably will come back to being, a regular departmental member. And if you've kind of put aside all of your research, then that becomes quite difficult to get back to doing that. So I always did try and keep some graduate students going, and we would always find time for meetings to try and keep the research moving along. Yeah, and I think it is important, actually, because if you become a pure administrator, you kind of lose a little touch with the people that you're trying to lead, and try to if you can. As an example, Elsayed, even though he was the Dean of Engineering here, with one of the largest faculties of engineering in Canada, he taught an undergraduate course every year. And I just was impressed that he always made that effort that he wanted to keep his contact with the students and to have a sense of, not to get away from the classroom. and so I think it's a good practice. Yeah.
Yeah, and I believe if you have a passion or you like what you are doing, you are trying to stay connected. If you like teaching, you will stay okay. You want to still teach, even if you have a higher admin position, and even you having all the release of your courses, you want to still connected with the students. But you mentioned that you did your PhD in the 80s. So I think the graduate study at that time was quite different from those days nowadays. So during your graduate study, there was a lot of challenges, a lot of good memories. Can you take us back on one of those challenges?
Well, it's hard. You have to think about just one, but
maybe a couple.
yeah, well, I think we talked a little bit about it already. Is that when I was preparing for my comprehensive exam, because I was working on a topic that I did not have a lot of formal coursework and things in, and touched on a number of aspects of biology and chemistry and chemical engineering. I was nervous about what kinds of questions I would get asked at my comprehensive exam, and so that leading up to that was probably a pretty stressful time, right? And probably is for most PhD students, right? That if you're not nervous before your comprehensive exam, then
there's something wrong.
There's something wrong. But so that was quite a challenging time, I think, just trying to anticipate how that would go out. And in retrospect, it turned out fine. And then in terms of really significant successes or really high times, I think back to when I was able to present my PhD research to the first conference that I presented at. It was at the Technical Association of the Pulp and Paper Industry. Because I was doing pulp and paper research, and it was a conference in San Antonio, Texas. And so it was really the first big conference that I had ever been to, and to present there was to be there was a real treat, to be able to share the work, and it turned out that my person that would become my PhD external examiner was there as well. He was there from John Ferguson from the University of Washington, and we had a chance to chat and to talk about the work, and he was very positive, and so having that kind of positive reinforcement at that stage, when you're just about to defend your thesis, was a very you came away from that feeling very, very good about yourself, and so that was a very positive thing that I remember.
So if you want to say something to the current PhD students that are preparing for their comprehensive exam and they are overstressed, what advice would you give them to relax them a little bit?
Yeah, well, we usually talk a little bit. I usually do try and talk to them a little bit about, where they might expect questions, right? And so we talk about what are the major features of your work. If you think about it, if you stand back and look at it from a little bit of a distance, where are you making your biggest contributions, or what are you drawing upon the most in terms of your work, and then think about, have you kind of got your background sort of knowledge there strong. I also tell them to look at who your examiners are, because most people ask questions in areas that they're comfortable with, and so do a little bit of homework on the examiners and try and anticipate the areas that they're going to ask, right? And so I think that helps. Hopefully, them give some guidance as to where they might spend their time, and then I say, well, if you get a question that you don't understand, well, just say that you don't know that. But
Yeah, you're a student. So that's okay.
right,
It's
yeah.
not
And
necessarily to know everything.
you may not be able to answer every question, and if you don't really understand or have an answer, just say it. Don't try and make up a solution, right? So.
Yeah, this is really an important point. And if I want to add to that one, so this comprehensive exam is to enhance your research. All the questions or the comments come to just improve the quality of your PhD. It's not like, okay, exam by means exam or criticizing you or challenging you. It's like more, okay, we want this to have something meaningful. So you did your PhD on the pulp and paper waste, industrial waste, and then most recently you're working with the wastewater and sludge management, nutrient. If you can just highlight the main research areas that you and your team are working on.
Right. So, I mean, we have work in our group on a number of topics. I'll probably just talk about a couple of the larger ones that we've been working on. And so we've been looking at a full-scale implementation of membrane aerated biofilm reactors, which is a relatively novel technology that has the ability to supply oxygen to bioreactors very energy efficiently, but it also allows us to create environments where we can get really significant nutrient removal, nitrogen removal in particular. And so we've had the fortune that locally there's been a full-scale installation of this novel technology, and we've been able to explore issues that have been experimented with at bench scale, but haven't been really addressed at large scale to see how things scale up. And so we've looked at nutrient removal, we've looked at energy consumption. We've been looking at nitrous oxide emissions because the technology has the potential to significantly reduce nitrous oxide emissions, which is a very potent greenhouse gas, 300 times that of CO2. We've been looking at the microbial community because it has this it's got both a biofilm component, it's got a suspended growth component, but even the biofilm component can change progressively along the length of the bioreactor. We've been looking at emerging contaminants in the system because the system with biofilms, we know that they are usually better at removing some of these more difficult to degrade organics like pharmaceuticals. And we also have a combination of oxidation reduction environments, both nitrate reducing and aerobic conditions, which also sometimes can provide an environment that will stimulate the degradation of them. And we have actually seen improved biodegradation of some pharmaceuticals with this system. So it's been an interesting project. It's very multidisciplinary. We've worked with microbiologists here on campus. We've also worked with some of the ecotoxicology people looking at the emerging contaminants. We've worked with some fairly advanced technologies, so microbial community characterization using genomics. We've looked at advanced analysis to be able to measure some of these pharmaceuticals in complex wastewater streams. So we've pulled together a lot of threads together, and so that interdisciplinarity has been interesting to be part of. I'll talk about another project, which is looking at microplastics.
Before we move to another project, for this project, it's quite interesting, but for the early researcher, if you simply explain what is the difference between membrane aerated bioreactors versus a conventional bioreactor.
Certainly.
So
when we think about conventional biological wastewater treatment, we often think about activated sludge, which is a suspended growth biological process, usually aerobic, or not always. And provision of oxygen to that kind of a system is very energy intensive. Right? It's like 30% of a municipality's energy consumption can be consumed for aeration. And part of that is because we typically bubble air through these very deep tanks, and so we need very high power blowers that consume a lot of electricity to do that. Membrane aerated biofilm reactors have modules of like spaghetti-like membranes that are immersed in the bioreactor, and the air is actually provided to the inside of the spaghetti, so blowing through what we call the lumen of the membrane, and oxygen actually diffuses through the membrane out into the solution where the biology is happening, and you actually grow biofilms on the surfaces of those membranes, and that's where a lot of the bioconversions happen. So it becomes the energy efficiency is largely due to the fact that you're not having to expend as much energy to provide oxygen through the membranes compared to having to push it against the water pressure in a deep aeration basin. And so you get savings of energy there. You also get typically a higher percentage of the oxygen that you provide to the system actually gets transferred into the water. So you don't actually have to provide as much air to these systems as well.
Yeah, so when you say, okay, it's a bioreactor and has a membrane, so it has biofilm. And when it comes to a biochemical reaction, typically modeling such process, modeling a conventional bioprocess, it's challenging. Because all of those biochemical reactions, physical reactions, and those stuff, when you add with biofilm, I think it's quite challenging.
So we've done quite a bit of work looking at modeling the membrane aerated biofilm reactors. We've collected field data from different aspects of the system to allow us to evaluate the model performance. And most recently, we've been looking at modeling this nitrous oxide emissions, which initially, they come from some of the nitrogen transformations that occurs in the bioreactor. So the approach that we've taken is to model what we call the conventional parameters first. So we've been modeling oxygen consumption and nitrogen, ammonia removal and BOD removal and so on. And we've established that as kind of a baseline for the modeling. And then once we had that, then we added the nitrous oxide biochemical reactions as well as the liquid gas mass transfer reactions to reflect how gases move and so on within this more complex system. So we kind of took a layered approach to the problem and trying to build up from basic to more and more complicated.
I see that you are so excited when you are talking about that process and that experience. It seems like it was a really quite interesting project to you.
It was quite an interesting project. It still is going on, and it brings together a lot of different things that we've worked on over the years with different technologies, but I think it's tied a lot of it together in this particular kind of application.
We always say there is no magic technology that can solve everything. Every technology has its own challenges. So if you want to highlight, what are the major challenges for this membrane aerated bioreactors?
I think some of the challenges are still going to be associated with low temperature operation. We've seen some changes in performance with low temperatures, and that will continue to probably need more attention as we go on, especially in a Canadian context. We always have to worry about, especially if we're looking at nitrogen removal and so on. But I think that there's progress being made on that. There are some of the issues are just around you know, the things, real practical issues around membranes kind of getting clogged and so on, with and maintaining biofilm thicknesses that are not too thick, so that we can get good movement of substrates and so on into the biofilms.
Okay.
Yeah.
So, nowadays, I'm quite interested in the artificial intelligence and machine learning because I have two daughters that they are in computer science. So I start to be quite a little bit interested in the computer science and artificial intelligence, and we're doing some work on that. And when I was looking for that, I found that you did some interesting work implementing the artificial intelligence tool and knowledge in your field.
Yeah, we've been working for a few years now looking at, this is with microplastics.
Okay.
And being able to develop improved tools for characterizing microplastics in wastewater systems. So, people have been looking at microplastics for quite some time, but the methodologies for quantifying microplastics are really very different between different studies. So often it's difficult to compare between studies the results, because some researchers are just looking at the plastics under a microscope and counting them. Yeah. Some of them are using some advanced microscopy, but the techniques are variable. So when we started looking at microplastics, at the very beginning, we thought, well, we want to have some good tools here for characterizing these plastics, and so we started looking at some advanced microscopy that basically generates three-dimensional kind of images of the microplastics, where you get these fingerprints that tell you something about the composition of the plastic, right? A spectrogram. And we wanted to be able to take that spectroscopic information and interpret it to tell us what kind of plastic these particles were. And this is where we started to look at the idea of using some neural network methods for identifying these plastics based upon the imagery that we were collecting with the microscopes. And so we worked actually together with a colleague in systems design engineering here at the university, Alex Wong, to develop an artificial neural network that could identify a range of different plastics. And we trained it with some known plastics, and then we tested it on some more complex plastics. And then actually we then went back and kind of trained it a second time with more complex plastics. And so what a lot of people may not realize or know is that plastics are not simple in practice. That they actually, you have what we call the base polymer of a plastic, something like polyethylene, polypropylene, polystyrene. But they often have other kinds of additives in them, so dyes and plasticizers and fillers. And when you use these spectroscopic methods to try and characterize the material, you get smearing of the spectrograms relative to what a simple kind of clean plastic would have. And so what we found was that with the neural networks that we developed, is that they could still recognize the basic plastic that was making up particles despite having these other kind of interfering materials that tended to make the spectrograms more complex and difficult to interpret. They were able to still extract the basic information that was there. And so that, I think it was an interesting use of artificial intelligence. I like to think of it as, I say, artificial intelligence for good, as opposed to some of the other uses that artificial intelligence is being used for. And it helps us, it gave us the ability to have more accurate estimates and also faster data analysis.
So did you give it a name?
It's called Plastic Net.
Plastic Nut. I'll remember that. Is it a tool that is available for other researchers or just still?
It's still kind of in the lab, so to speak,
Okay.
right? I think the PhD student that developed it. I think we've talked about trying to perhaps improve the user interface to make it so that it's a little more usable by other practitioners and so on. So I think we will make it available. It's just a matter of that. I think it needs it was developed and built for a particular individual, but often when you have other users, you need to make the interface a little bit more user friendly.
So I would say this tool have more advantages over the other measurement or monitoring tools for the microplastic. I know that one of the major challenges for the emerging contaminant in general, and specifically the microplastic, is how to count them or how to measure them.
Right.
I think this is a great tool as a start with to maybe overcome one of those challenges, which is quite interesting. But it looks like you are really enjoying your life as a professor.
Yeah, I'm pretty in a pretty good spot right now. I think I'm having a chance to do a variety of different kind of research, and teaching is interesting.
So, what is the most favorite part of being a professor?
Well, if I think about breaking down my day into the kind of major things that I do, I think the part that I really enjoy the most is actually the one-on-one or the one-on small group interactions, right? Where you get a chance to really to know students, to give them very focused attention and to learn from them a little bit about what's happening with them and motivating them, and both from graduate students but also undergraduate students. I every year I usually supervise a couple of fourth-year capstone projects.
Okay.
And some of those projects are very close to research that I do, but sometimes they're projects where students have picked something that's kind of interdisciplinary, and I can help them with some of it, and some of the times they have to get some support from others. So this past year I had a group that was doing fish farming.
Yeah.
And they were wanting to be able to look at on-land fish farms where they could be more sustainable. And so one of the things they wanted to be able to do was to have the fish growing in these raceways that where the temperature was not elevated, where basically they were using the ambient temperature, which meant that they had to, all aspects of the system had to work at lower temperatures. And so one of the things that is part of these systems is they recycle the water around the raceways. And so that means, and ammonia starts to build up when you do that. So they usually have a biofilter system for biodegrading the ammonia. And so they needed, one of the upgrades that they were looking at was how to design a biofilter that would operate at lower temperatures. Okay. And so that was my part of the project, was getting them to look at this from a good solid mass balance standpoint, as well as implementing some of their environmental engineering principles to size this biofilter. And then they went off to biology and they talked to the biologists about things that would, from the fish growth standpoint, that would be impacted by lower temperature operations. So they really kind of tied together, two different areas into this project. But it was an interesting project, and it was interesting to get to know these students. And of course, over the years, I've supervised a lot of different undergrad and grad students, and I've always found these kinds of interactions to be quite.
But it's quite interesting that most of the projects that you are working on are like interdisciplinary projects. I think now this is the kind of thing that is for our field that always require an interdisciplinary.
Yes, I think actually of all the projects that we've done in the last while, the ones where we've interacted with people from other disciplines have been some of the most interesting, right? So I've worked with people from chemistry, biology, earth sciences, chemical engineering, systems design engineering,
and computer science now, for artificial
and a little
intelligence.
bit of computer science, yes. And so you do have to learn new vocabulary, right? So that's
Exactly.
so sometimes you may be talking about the same issue, but we have just different ways of talking about it or describing it. And so learning that vocabulary and listening to the other side it does take it does put you out of your comfort zone sometimes, right? And you kind of
like that. So that was maybe a favorite part of being a professor, but always there is some, I would say, the least favorite part, or some stuff that you don't like being anonymized.
I really don't like marking.
I agree with you. I think every professor would agree.
I'm so happy that we actually get good teaching assistants who help me out with a lot of the marking of assignments. I still mark midterms and exams because I really want to know how people are progressing in the courses and so on. But a lot of the other marking of assignments and so on, I'm very happy to have somebody else do that.
Yeah. So maybe you came to marking, so you mentioned to the teaching. So I think education before pandemic is different than after the pandemic. Let's focus on teaching before pandemic is something, and after the pandemic is something else.
Yes, certain things have certainly changed. What I've observed, and actually I've talked to a number of my colleagues about changes, is that attendance in classes is low, and it's a little surprising that people don't feel that they need to attend lectures. I don't quite understand. I haven't talked to a lot of people, but I kind of hope that is something that is only a temporary transition, and that we'll get back to more regular kind of attendance, because I think that's part of the value of the education is being in the classes and learning from that, right? So some of the other things though, there's been some definite things that I think we're doing better now than we did before. And, a lot of the use of video systems and so on for having meetings and group meetings and so on, and being able to have the ability to transfer knowledge in other modes, I guess, than just a traditional way. I think that probably has definitely improved in the last, compared to where we were before, right? We have more flexibility, I think, in the ways that we can do things.
I agree with you that it saves some time. But actually, I spoke with some students regarding that attendance, because I have two daughters in my family, in my house, that is going to university. And I spoke with them, okay, what is the reason? And they said, all the materials are online. So during that couple of years of pandemic, when we recorded the lectures, and to somehow they get access to it, so it's there. So all the material there is online, and sometimes it's, if the class itself it's not interactive and interesting, we have the technical stuff would go to that. But hopefully, with time, the things getting improved a little bit. Let's take you away a little bit from your, professional and professor, to your personal hobbies. What is your personal hobby or passion?
Well, I have a couple. Okay. I very much a proponent of an active lifestyle. And so one of the things I do is I cycle.
Yeah.
I do a lot of cycling, and I sometimes use the cycling as an opportunity to actually think about things. And so some of the times that I do actually solve some work-related issues in my mind while I'm cycling. but I also, I bring a little bit of it into my classroom as well.
Oh.
So in fact, the last course I taught, I went through my course notes and I inserted little bicycle icons in key places.
Okay.
And where, things really core concepts. And
I like that.
And so I said to the class at the outset, I'm a keen cyclist, and when we come to key concepts, you can look in my notes and there will be a bicycle icon. So if you're wanting to know if something is really important or not, look for that. So yeah, I like to cycle. I also like to ski in the wintertime. And I think, if you're living in Canada and winter lasts for 4 months, you want to do things that make winter enjoyable. And I find skiing a very enjoyable way to spend the winters. So I do that. And then when I was 48 years old, I learned how to snowboard.
Oh.
And so I kind of mix up a bit of traditional skiing and snowboarding, and I always say to people, well, if I can learn to snowboard at 48, you can learn.
Okay. Can learn
something else too. So, those are my kind of two sort of real diversions away from work, I think, in terms of activities anyways. Yeah.
So that's quite interesting, but it takes me to think about, if Wayne Barker is not a professor, what would you be? What other career would you choose if you are not a professor?
Well, I still kind of think of myself as a wastewater process engineer, and I think if I wasn't a professor, I think I would be pursuing that as a profession, right? And
now let's look at something away from environmental engineering. Not engineering, not environment, not a professor. Something.
You're asking me to go far afield, right? I've always, I guess I've been an engineer for so long. I kind of don't know how good I would be in other areas. Probably in science, I think.
Okay.
I think there are certainly some areas of science that, some of the ecotoxicology work I think is really interesting to, and I guess I've had some exposure to that through my collaborations with.
But again, it's something you do with your brain, not a handy work or something like that.
Oh, well, I've always been, construction. Over the years, I grew up doing a lot of construction before I went to university. And so over even, with DIY projects at home and so on, doing renovations and so on. I've done quite a few home renovation projects over the years, and I find those interesting as well. And certainly there are aspects of that I think in some days it would be interesting to pursue that as a career as well, right? If I wanted to do something completely different and something that was more kind of hands-on, I worked as an electrician's assistant for a summer one time. I actually enjoyed that as well. So in fact, I actually, when I first went to university, I was thinking about being an electrical engineer at the time, and at that time we had a common first year, and so I was actually admitted into electrical engineering, but it was all common, and so after first year I kind of made the decision that I kind of what I saw in the civil engineering seemed more interesting to me, but I've done a lot of electrician work as well over the years with wiring of houses and that kind of thing. Yeah.
But did you get any electrical shock when you are there?
Had some close calls.
Okay. So our students, when it comes to making a decision about their career, if we look at the PhD students who are looking for their future, and sometimes they come to you and ask you, I don't know which path should I choose. Shall I go to industry or shall I go to academia? I think you are receiving such questions from a PhD students. What would you advise them to tell them?
Yeah, I think that's a common kind of question, right? So I think most people, when they start out as PhDs, they think that they're going to become professors. That's their vision, right? And that's kind of one of the motivations. But the reality is that only about 20% of PhDs become academics. If you look at the big picture statistics, so and there are a lot of things that affect the decisions that get made about hiring people into academia. So I always recommend that people think about preparing themselves for both pathways while they're grad students, right? So keep a broad perspective on kind of what is going on in the industry. Try and network, right? Try and yes, you have to do your research, but look around and take opportunities to meet people from industry. Like go to conferences when you can, and when you're at conferences, try to take advantage of them in terms of broadening your network of contacts, and to learn about what's going on in the industry, right? So that you can kind of prepare yourself a bit strategically, right? So that you kind of can go, presumably both directions, depending upon what opportunities come along as you graduate and so on. And so I think it's just good kind of risk of management, right? Or due diligence, and to some extent, also think, look around and see exactly what it is that professors do. Because sometimes it's very tempting to think that, professors have this glamorous role all the time, and you're traveling around the world and you're presenting at conferences, but also, try and see what happens when when you're preparing for lectures, and what it means to be up in front of the classroom on an ongoing, day-to-day basis, right? Is that something that you really want to do? Does your personality fit with that kind of thing? Because it is a little bit of a different thing when you get up in front of a classroom than when you're sitting in the classroom looking at the other direction, right? So really, learn a little bit about all aspects, right? If you can, take advantage of an opportunity to say TA a course, or to teach as a sessional sometimes, right? And get that exposure, so that exactly, you have a better sense of what it is that you're actually getting into as an academic, right?
Yeah, because sometimes the students came, especially for international students, so the model is different there. So once they graduate from the bachelor, they can hire directly to the university. So they have that mindset, I want to be a professor. So when they do their PhD, they have one mindset, oh, I want to be a professor. And they don't open their mind for other opportunity for like industry, which...
And as our technologies become more sophisticated in the environmental engineering world, there's a need in the industry to have people who are much more highly and specialized training, right? There are interesting opportunities that one can have in industry where you do get to look at some pretty sophisticated problems.
Yeah. So if you have a new graduate student coming to your office for the first meeting, and just he's going to start her or his research, what advice would you give her or him?
Well, I think probably one of the more common things I say to them, and this is more an approach kind of thing to any kind of academic study, is really to try and treat your graduate studies like a job. That, because graduate school is so different than being an undergrad. Where as an undergrad, you have all of these very short-term commitments, right? You've got to get assignments in, you've got midterms, you've got exams, and somebody's telling you what you need to do all the time, right? And so you actually have very little control over your agenda. But as a graduate student, all of a sudden, you're not doing very many courses, and yes, you have to get this thesis, but that's a couple of years away, and it seems like there may be some more interesting things to do with your time, right? But almost always, it still takes the same amount of work to get to that end point, and if you choose to put it off towards the end, you will find yourself more stressed. Whereas if you can kind of look at your work and work on it steadily from the start, and do some of those things early on and get them out of the way, so that you will get the work done in the time, and you'll be much less stressed in terms of and probably the work will be done better. So I really advocate taking that kind of very kind of steady approach. Work regular hours. You don't have to work till 2 a.m. You can work regular hours, and I think things just go better if you take that kind of general approach. And I tell almost all my grad students to think about their studies in that way, because it is a different kind of, much more self-motivated, self-regulated kind of experience.
Okay, so we came to our last question. So this is your camera. So if you look at this camera and give some advice to our young water professional or young researcher, what would you tell them?
Well, I think I would tell them to, really think strategically about your studies and about your profession, about what do you, where do you want to go with your career, what kind of preparation you should have, and to whether it's technical or non-technical preparation, right? Sometimes some of those non-technical skills, those communication skills, can be just as important to having a successful career as knowing how to solve a particular kind of analytical problem, right? And to think a little bit bigger picture, right? Don't think just about what you can do, but why you're doing what you're doing, and how you can make a contribution to the profession, right? And that is something that will allow you to market yourself if you're entering the workforce, if you really truly understand where your work is advancing our knowledge base or our profession. And so think more than just about I have to get this thesis done. Think about the bigger way that you prepare yourself for your profession.
Dr. Barker, it was really a pleasure talking to you today and remembering those days. Thank you so much for
thank you.
this meeting.
It was a very nice talk.
Yeah, thank you so much. So thank you so much, everyone who are following us. And I think we have a very rich episode today with Dr. Barker. And looking forward to see you in the next episode. So stay tuned.